Welcome back, everyone. So we're going to start Unit 4, which is on rational functions. So we'll kind of jump into Module 9 first and then head back to Module 8. Module 9 is focused on operations with rational expressions. So we'll just note that our rational polynomial function looks like a quotient of two polynomials. So it's going to look like maybe two linear polynomials, x plus 7 over x plus 3. Or maybe a quadratic over a cubic, etc. But in general, we're going to have this ratio of polynomials, which means that we might be able to use factoring techniques to simplify our polynomial. And then after looking at all of these different operations, the Module 8 notes will focus on what the graphs of these functions will look like. So for today, we're going to focus on operations. So what happens when we take rational expressions that are written as polynomials instead of numbers, and how do we combine them through addition, subtraction, multiplication, division, as well as just simplifying? What we're going to do in each case as we work through them is look for these undefined values. So undefined values are simply going to be division by 0. So where are the expressions where we need to worry about dividing our expression by 0? So we'll start with just simplifying expressions. So we're going to take these rational expressions and simplify them as much as we can, and then identify those undefined values. So what we'll note for number 1 is we've got two quadratics, so we'll definitely want to make sure that we can factor these, and if so, what are the values that we can cancel? So for our numerator in number 1, it looks like we'll have x minus 3 times x plus 1. In our denominator, we're going to have x plus 4 times x plus 1. So it looks like we can definitely cancel an expression. But before we do that, we are going to write out our undefined values. So what can x not equal? And essentially, x is not going to be able to equal anything in the denominator when it is 0. So for x plus 4, that is going to equal 0 at negative 4. And for x plus 1, that is going to equal 0 at negative 1. So our undefined values for this expression are going to be x equals negative 4 or x equals negative 1. So we're going to exclude those as possibilities. Now we can cancel. So we get our simplified expression is simply x minus 3 over x plus 4. And what we're going to find is that that divided out factor is going to form a whole when we actually graph it. So it's an excluded value from the domain if we thought of this as a function of x. X plus 4, however, is going to be a vertical asymptote, which means that's going to be where our function breaks down and either approaches infinity or negative infinity. Okay, so you might want to go ahead and pause the video here to go ahead and try 2, 3, and 4. They're all similar ideas where we're going to be factoring in order to complete the simplification of the expressions. So let's go ahead and look at, number 2. Don't need to zoom in that much. So again, we will factor the expression if possible. Note this one, we've got a leading coefficient other than 1, so we might need to do a bit of guess and check. So perhaps 3x and 2x will work. Let's see. So we need a 13 in the middle, negative 13. So maybe negative 5 here, because that'll give us negative 15x. And then plus 2x, so I think that works. So for our denominator, we're going to, again, make the assumption that it's 3x and 2x. We'll note it could be possible that it's 6x and x as well. So we might need to go back and check if this fails. So we need to add to negative 23 in the middle, but multiply to 7. So I think we want minus 7 to get negative 21, and minus 1 to get negative 2x. So I think that works. Good. And what we'll note here is that nothing cancels. So don't assume that everything is going to have factors that cancel, right? So this is actually already fully simplified. So we don't need to do any more work, but we will note what x cannot equal, which again is those denominator values. So 1/3, and it looks like 7/2. The numerator, we'll just note we don't mind having zeros there because we can take 0 and divide it by any number we want. So the numerator values are not going to factor into our domain discussion. They will factor in, though, for the roots or x-intercepts of our equations. So for number 3, we've got, zooming in again. We've got 4x minus x squared over x squared minus 2x minus 8. So we'll note we can factor out an x here, and we'll have 4 minus x. And then this is going to factor as x minus 4 times x plus 2, I think. So again, we'll note the undefined values. So x cannot equal 4 or negative 2. And then we'll note that we can cancel x minus 4 and 4 minus x, but we'll note it's going to leave us with a negative 1 since they are opposites of each other. So that means we're going to get negative x over x plus 2. And we could distribute the negative to the denominator if we wanted to as well. So again, it doesn't matter in this case. Number 4, we've got... can factor out a negative x, and that might make our expression look a little bit different. And so we'll get x minus 3 when we factor. And then in our denominator, looks like we're going to need 2x and x, and we need to get negative 7 in the middle. So I think negative 3 and negative 1 are going to work here, and they do. So again, we'll note x is not equal to a half or 3. But we are going to get cancellation. So our expression is going to simplify to negative x over 2x minus 1. Okay. So this is going to be kind of our general first step for most rational functions. Next, we're going to look at multiplying. So we'll look at these 2 examples, and then we'll take a break, I think, and then start the next video. So for multiplying, again, just like multiplying fractions, you're just going to multiply straight across. So numerators multiply together, denominators multiply together. So if I'm multiplying this, what we'll note here, though, is that because we're multiplying, we can do some cancellation first. So we can cancel 9 with 45, and we'll have 5 left over. We can cancel x to the 9th with x to the 6th, and we'll have 3 left over. And then we can continue in this fashion, cancel the 5 and the 15. So we'll have 1 and 3, and then we can cancel one more x out, and we will have x squared. So cleaning this all up, we'll end up with 1 over 3x squared for our final expression. We probably could have done the undefined values first, but it remains the same, which is just 0. So the denominator cannot equal 0. For number 2, if we've got binomials as opposed to these monomial terms, now we'll want to factor first. So we're going to get x minus 3 times that quadratic, which looks like it is x plus 4 quantity squared, all over x minus 4 times x plus 4, factoring the difference of squares, times x squared plus 2x minus 15, which is x minus 3 times x plus 5, it looks like. And then again, before we do any canceling here, it'll be a good idea to do all of our undefined values. So plus or minus 4, 3, and negative 5 if we look from left to right. And now we'll do any canceling that we can. So we can cancel out an x minus 3. We can cancel out an x plus 4. And that's it. So we're going to end up with x plus 4 over x minus 4 times x plus 5. All right, so that's going to be the first page of the notes here. So we'll go ahead and take a break and come back for video part 2. So until I see you next time, take care.